Hey guys, so today I'm going to be working on an FRQ problem. I'm going to try to make it as interesting as possible, but bear with me, this is math. Today I'm working out problem number 6 from the 2007 AP test, and I'm going to go through how to do the problem and how it is scored. To start off, we are given a function f of x equals e to the power of negative x squared. Now part A is asking us to write the first 4 non-zero terms and the general term for the Taylor series for f about x equals 0. What a mouthful. So first let's analyze what the problem is asking for. It's asking for non-zero terms and a general term. What do those words actually mean? Now, Alexa, what does non-zero mean?
Non-zero is usually defined as not involving zero.
Now that means that this can be equal to literally any number value that isn't zero. So 0 is going to have to be left out for this.
All around me are familiar faces.
Now, keep in mind that this does not mean the same thing as fourth degree polynomial. A fourth degree polynomial entails that we are creating a polynomial to approximate the number to which the series converges to at a certain x value with a multiplicity of 4. Wow, that was too many big math words. Now, take a minute to process. Okay, moving on. We can talk about the general term. Alexa, what does general mean?
As an adjective, general can mean applying to all or most members of a category or group.
I guess this is sort of true, but mainly in this context, the general term would be the series representation, or whatever is normally after the sigma. This is the term that includes values of n. In solving the actual problem, we need to find the series representation for e to the power of x. Once we have that, we can plug in negative x squared in for x, and with a little bit of magical algebra, we end up with the series presented on the board. Since the problem is asking for the first 4 non-zero terms, thank you, Alexa, for your help.
Of course.
We simply need to find the terms where n equals 0, 1, 2, and 3. After putting these terms together, we end up with the equation shown on the board. Important side note, we don't need to worry about centering the terms at any number because the function is centered at 0. But if we are required to center it at a different number, for example 3, we would simply make the x term an x minus 3 rather than simply x. Yet again, 0 is the exception.
All around me.
Now, some people might try to write out the polynomial using the derivative technique, where you find the coefficient of the term by using the first, second, third, fourth, and so on derivatives, multiplying by x minus a, the term that the function is centered at, to the power of whatever derivative it is, and dividing by the derivative number factorial. In this case, that requires too much work and just gets confusing because of chain rule, so we should avoid that in this scenario at all costs. Now if we look at the scoring guide, it gives us 2 points for getting the 4 non-zero terms and 1 point for the general term, so we have covered all our bases. Now, on to part B. I know, but this one isn't so bad. It's asking us to use our answer from part A to find the limit as x approaches 0 of 1 minus x squared minus f of x all over x to the 4th. It looks scary, but it isn't that bad. So first, let's look back at our equation from part A, and the first step would be subtracting the function from 1. In doing that, we lose our first term.
I'll never let go. I promise.
And all of the signs are switched. Then, we can move on to subtracting by x squared. We lose another term. Now, with part 3, we divide by x to the 4th. In doing this, we can write out the equation. The last part of this problem would be finding the limit as it approaches 0. The series in x to the 6th over 6 will go to 0, and we are left with negative 1/2. The scoring guide is pretty self-explanatory for this one. Part C asks for the first 4 non-zero terms of the Taylor series for the integral from 0 to x of e to the power of negative t squared dt about x equals 0. It then asks us to use the first 2 terms of the answer to estimate the integral from 0 to 1/2 of e to the power of negative t squared. When attacking the first part of this problem, we can use the first 4 terms of our answer in part A because they use the same function and simply integrate each term in terms of x. For example, the term 1 would become term t, and term negative t squared would become t cubed over 3, and so on. Since this problem is not asking for the general term, we don't have to worry about integrating it. After integration, we are left with x minus x cubed over 3 plus x to the 5th over 10 minus x to the 7th over 42. Now for the second half, the problem is basically asking to estimate the value of the function where x equals 1/2, only using the first 2 terms. So all you would do is plug in 1/2 into x minus x cubed over 3, and after algebra you would get the answer 11 over 24. The scoring guide for part C gives 2 points for the polynomial with 4 correct terms and 1 point for the correct estimate, all bases covered. Finally, we move on to part D, error.
No! No, no, no! No! No, 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 no! No!
What? No.
No!
No. No, no. No, 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 no.
Honestly, this problem is not that bad. It is asking us to prove that the estimate found in part C differs from the actual value of the integral from 0 to 1/2 of e to the power of negative t squared dt by less than 1 over 200. Since the series is alternating, we can ensure that the error is less than 1 over 200 by using the next term in this series and seeing if it is less than 1 over 200. When 1/2 is plugged into x to the 5th over 10, the value that comes out is 1 over 320, which is less than 200. We then must show a long proof of why the answer is valid.
Seriously!
Seriously!
The proof reads that the answer is valid because the integral from 0 to 1/2 of e to the power of negative t squared dt equals the series starting at 0 and going to infinity of negative 1 to the power of n times 1/2 to the power of 2n plus 1 all over n factorial times 2n plus 1, changed because of integration, since the series is decreasing in absolute value to 0. The scoring guide for this problem gives 1 point for the use of the third term as an error bound and 1 point for the explanation. With that, we are done.
Finally.
Thank you for watching and good luck on that AP test.